Linear perspective can be very intimidating. It also seems like you need to have an engineering degree and 1,000 hours of computer training before you can make anything more complex than a cube. It can seem overwhelming, but you only need to be able to understand a few key elements before you can start thinking in 3 dimensions. And that's the real goal of learning linear perspective. Linear perspective is a mathematical device used by artists and designers to give the appearance of a 3-dimensional space on a 2-dimensional surface. This technique, in its current form, was first used by Italian artists in the early 15th century. Before then, artists sort of knew about perspective, but they didn't really have it quite figured out. Their buildings would look pretty strange, and there would be these awkward areas that really didn't seem to make any sense. So until the year 1413, artists basically said, good enough. It's also important to note that linear perspective is just a device, attempting to give an approximate representation of how we see. The way we actually see is pretty complex. We have these 2 cameras that are constantly moving and scanning, giving us an interpretation of the environment and its constant motion. Later, we're going to examine how modern artists and contemporary artists have played with this idea in perception. In this video, we're going to look at some of the main components of linear perspective through 1-point perspective and 2-point perspective drawings. When you're starting with any perspective drawing, it's smart to first establish the horizon line. This establishes the line to which all materials recede to. It also establishes the eye line. Changing the eye line and horizon line can have dramatic effects when properly used. Creating a low horizon line can give the effect that everything is large, just like a high horizon line can give the feeling that we're looking down upon a scene. This creates a tunnel effect where all elements recede into one point. This point is called the vanishing point. Once you have a horizon line, you want to create a vanishing point. In 1-point perspective drawing, there's one vanishing point. The vanishing point is where all receding lines converge. A perspective drawing is defined by the number of vanishing points it has, in this case, 1. In 1-point perspective drawing, all vertical lines remain parallel, as do all horizontal lines. The baseline establishes where an object is on the picture plane. It is the line that shows the viewer the bottom of the object. If the baseline is very close to the horizon line, it is going towards the background, further away from the viewer. If the baseline is further away from the horizon line, that item shifts to the foreground, closer to the viewer. Combining the ideas of a baseline and a horizon line help establish this idea of scale. With the bare information provided in this example, the bottle on the right looks smaller. That's because the baseline is the same with the bottle on the left. When we move the bottle up, we shift the baseline, pushing it closer to the horizon line. This changes the relative scale of the bottle. The bottles now appear to be the same size. The bottle on the right just now appears to be farther away from us. 2-point perspective is used when we want to show more than one side of an object. If we're looking at a cube, a building, or a person, we use 1-point perspective to show the front of that object. If we turn that object between the front and the side, we reveal 2 sides at the same time. We refer to this view as a 3/4 view, for which we need to utilize 2-point perspective. 2-point perspective has 2 vanishing points, both located on the same horizon line. If we're drawing a cube, and we don't want the object to appear to be distorted, the 2 points should be far away from one another. Next, we need to establish the baseline. This point will be where the front edge of the cube appears on the picture plane. If we draw the baseline, and the front edge of the cube below the horizon line, we, the viewer, will be looking down on the cube. If we're drawing a cube, all lines will either recede to one of the 2 vanishing points, or run vertically, 90 degrees to the horizon line, like the front edge of this cube. So, to create the sides of the cube, we will run the top and the bottom points of the front side to both vanishing points. This creates the sides of 2 faces of the cube. This basically just looks like a long fence receding to the horizon. Now, we need to establish the 2 vertical lines that represent the outer edges of the cube. There is a mathematical formula to get the exact location for a perfect cube, and if you want to spend an hour researching it and watching a 45-minute video on YouTube from an engineering major, I'll make sure I let your math teacher know you went to the trouble. But this is art class, so I'm just going to say right here looks about good. Now that I have the baselines established for these edges, the vertical line now gives me the top left edge and right edges of the box. For my final step, I'll just connect those points to the corresponding vanishing points. Erase the guidelines, and that's it. It may seem dull to spend this much time creating a cube, but once you can create a cube, you can create more complex shapes. And once you can combine those shapes with the other shapes, then you can create really complex shapes, things, stuff, whatever you want. Most importantly, with practice, you'll have an understanding of the concept of perspective, and you'll be able to start thinking in 3 dimensions when you develop ideas, which is really where you want to be.